All right, welcome to task 2. We're going to work on rounding this time. So let's look at some of our problems. So if we look at rounding, regardless of our place value for rounding, our rule stays the same. So if we look at our numbers between 0 and 9, okay, 4 and 5, that's our tipping point. Okay, anything 4 or below, so 0, 1, 2, 3, 4, is going to keep a number the same. Whereas anything 5, 6, 7, 8, or 9 is going to bump it up. I feel like that's a song. Now, what it does is when it bumps it up or when it stays the same, basically anything after that place value, which we talked about in our last task, it's going to revert back to 0. So anything from that place value on to the ones place is going to revert back to 0. So let's look at what we're talking about. What we're going to do is we are going to underline the place value of where they want us to round to. So if we want to round the following numbers to the nearest 10, okay, I'm going to underline the tens place. So the tens place is here. That means that what we're actually looking at is the 3. So the 3 falls right here, which means it's in the same. So that means the 3 is keeping the 1 the same, okay? It doesn't mean the 3 stays the same. It means the 3 is keeping the 1 the same. Because remember, we're rounding to the nearest 10. The tens place is the place that we care about. So basically here we had the choice. We could either stay the same or bump up. So we were either going to stay at 1 or go to 2. Okay, since we are staying the same, we didn't have enough to bump to 2. We didn't have enough for this. We are going to stay at 1. Everything past that is going to revert back to 0. Well, we only have one thing, which was that 3 that didn't have enough to bump up to the next number, right? Or didn't have enough to bump the 1 up to the next number. So that's going to revert back to a 0. So this actually rounds down. This is why we say rounds down to a 10, and we're done. Okay, so 23 is actually really similar. We're just 10 more. Okay, so since we're rounding to the nearest 10, again, the tens place is this 2, which means we're using this 3 to determine what to do with the 2. So again, our two options is stay the same at 2 or bump up to a 3. Well, the 3, again, is right here. That's in the, quote, same, okay, section. So I don't have enough to bump up to a 3, which means the 2 has to stay at a 2. And everything else behind it reverts back to a 0. I only had one place. And here's the deal with math. If it walks like a duck and it quacks like a duck, it's a duck, okay? If a problem starts out as 2 digits, it's going to end as 2 digits. If something starts as a binomial, it's going to end as a binomial. It's like the conservation of mass in science. If something starts as 25 grams, it's going to end as 25 grams. Even if you have and this goes to the idea of water water to ice to like vapor. Whether water in its liquid state or in its solid state as ice, it takes up the same, like it is the same. Okay. Now listen, I'm not a scientist. That's my husband's job. I'm not doing it justice explaining it. However, there are scientific laws which protect that, right? It works the same way in math. This started out as a 2-digit number. It needs to end as a two-digit number, which means that like when I say everything after that reverts to 0, how do you decide how many things revert back to 0? Well, it was only a 2-digit number to begin with. So you know the 2 stays a 2, and then essentially, like if you write that there, it's only a 2-digit number. So you only need to fill one blank after that, which now needs to be a 0. Okay, so your answer is 20. Now let's look at 18. So if we're rounding to the nearest 10, that's the tens place, the 1. The 8 is going to decide what the 1 becomes. Does it stay a 1 or does it bump up to a 2? Those are always my two options. Does it stay the same or does it bump up? It's never going to go down. Okay, it's stay the same or bump up. So does the 8 keep it a 1 or does it bump it up? 8 is up here, which means it bumps it up. So it does not stay the same. It bumps it up to a 2. And again, 18 is a 2-digit number to start with. It needs to stay a 2-digit number, but anything after that first digit reverts back to a 0. So this also becomes a 20. So it's interesting, letters B and letter C, 23 and 18, when they're rounded to the nearest 10, they both actually become 20. So like if you have $23 in your pocket and you have $18 in your pocket, and you're both rounding to the nearest 10, you say like, oh, I got 20 bucks in my pocket. Okay. Now, do you really have the same amount of money in your pocket? Because money usually makes sense to people, right? Because you know how much money you usually have in your pocket or in your bank account, right? No, you don't have the same amount of money in your pocket. Okay, one of you has a little bit more and one of you has a little bit less. If something costs exactly $20, one of you is going to have enough to buy it and the other is not. However, if you're rounding, if you're saying approximately how much money do you have in your pocket, you're both going to be able to get away with saying like, oh, I have about $20. All right, let's look at the next one. Rounding to the nearest 10. So again, you're looking at this 2. Okay. So then the 6 decides what the 2 becomes. It's either staying a 2 or it's bumping up to a 3. The 6 is right here, and that's in that section of bump it up. So we're not keeping the 2, we're going to 3. Started as a 2-digit number, needs to stay a 2-digit number, reverts back to 0. So 26 rounds to 30. Okay, and now 24. Rounding to the nearest 10, we circle the 4. Okay, the 4 makes a 2 become what? Does it stay a 2 or does it become a 3? Okay, a 4 is right here and it's right on the edge, but it's still on the lower edge, so it needs to stay the same. So it's a 2-digit number, reverts back to a 0. So it rounds to a 20. So again, if you look, 23, 18, and 24 all round to 20. 26 rounds up to 30. 13 rounds down to 10. So you see this grouping of all numbers that are pretty similar and how they round differently. Okay, let's look at the next group. Excuse me. Rounding to the nearest 100. So now 100 from your place value chart, you know, is the 3rd digit to the left. Okay, so if I just go through and underline it, I'm at 1 here, 2 here, 1 here. Oh, I actually don't have a 100 digit there. We'll have to talk about that one. And then 2 here. Okay, so let's start going through. If I underline my digit, my hundreds digit, I always go one to the right, okay, to help me decide what I'm rounding. So this 4 rounds the 1 to what? Well, 4 keeps it the same, so I'm going to keep a 1. And now again, everything reverts to a 0, but now a 3-digit number stays a 3-digit number. In order to keep a 3-digit number, I need 2 zeros. So 140 rounds down to 100. In letter B, a 6 rounds that 2 up to a 3. And again, to keep the 3-digit number, I need 2 zeros. So 260 rounds up to 300. In letter C, that 8 rounds the 1 up to a 2. To keep the 3-digit number, I need 2 zeros. So 180 rounds up to 200. Now, here's this interesting one. It almost caught me. I was flying through and I almost underlined the 9 for my hundreds digit. Now, honestly, this one doesn't have a hundreds digit, and you might want to say like, oh, can't do. But realistically, you might be able to do this one, because if you look, the hundreds digit, you could underline like right here, which is blank right now. And if you look one to the right at the tens digit, that's this 9. Well, the 9 is going to do what? You could really put a 0 here, right? There's 0 in the hundreds digit. What is the 9 going to do to that 0? 0 can either stay a 0 or it can bump up to a 1. The 9 is going to round the 0 to a 1. And then it's going to revert the next 2 digits to zeros. So 94 rounded to the nearest 100 is going to give you 100. All right? And then for this final one, the 4 is going to round the 2. Well, it's going to keep the 2 the same, right? Because 4 is right here, and that's in the same part of the 0 to 9. So keeping it at 2, we're going to fill in the 2 zeros, and 246, while really, really close to 250, that tipping point, that midpoint between 200 and 300, it's going to keep 246 is going to round to 200. All right, so let's do the same for the 1,000. All right, 1,000 is the 4th number to the left. So I'm going to go through, and again, I'm going to underline. This one, there are no tricks. I am able to go through and underline them all. I'm going to circle the one that is next to them, to the right. Okay. 3 keeps the 2 the same. So I'm going to get 2. And again, keeping them 4 digits long, I'm going to add 3 zeros. 9 turns the 2 to a 3. And I'm going to end up getting 3,000. 4 keeps the 3 the same. And I'm going to get 3,000. So again, there's that 2,900 and 3,400. They both round to the 3,000. The 6 rounds the 3 to a 4. And I get 4,000. And then the 3 keeps the 2 the same. And I get 2,000. So you see, like A and E here, it really didn't matter what you had in those last 2 digits, because the 3 is driving the bus, right? So that 3 is telling that 2 what to do, okay? And it's telling that 2 to stay. and then it's reverting everything back to zeros. So you do get the same answer and everything else disappears. All right, we're going to do the same thing with the nearest 10,000. So 10,000 is going to be the fifth digit to the left. So I'm going to, switch back to pen. I'm going to underline it. I'm going to circle the next digit to the right, which would be my 1,000. Okay, and the 8 makes the 2 into a 3. And again, I'm going to fill in so that I have 5 digits altogether. The 2 makes the 3 stay a 3. So again, here's a situation where you have 28,000 and some change, rounding up to 30,000. You have 32,000 and some change, rounding, to 30,000. I hate, hate's a strong word, but I dislike saying rounding down because again, you're not changing that 3. That 3 is staying the same. 4 keeps the 1 a 1, and then you get a bunch of those zeros to get 5 digits all together. 1 is keeping the 7 a 7. Whoops. And you get 70,000, and 1 keeps the 4 a 4, and you get 40,000. All right, here's an interesting one. We have to round to the largest place. So we have a bunch of different numbers, different length numbers. So A, we have 705,418. So we are going to underline the 7, circle the 0. Here we're going to underline the 3, circle the 1, underline the 5, circle the 2, underline the 2, circle the 5, underline the 8, circle the 0. So here, really what you want to do is you want to make sure you are underlining the most left digit and you're circling the one right to the right of it. And when you decide whether you're keeping or you're bumping up, and then you want to revert everything back to 0 and make sure the length of the number in digits matches. Now, I'm starting to, move quickly through these. You've probably figured out that you can speed up YouTube and speed up the video so that, you don't have to let my voice drag through these. I probably sound like a chipmunk at this point in the videos. You can also stop and pause these videos, rewatch, and you can pause to check and work ahead of me to see. And this is a good feature. So, like if you want to stop right now, try all 5 of these, see if you get the right answer, and then let me do them and, check your work. That would be a good thing to try now too. All right, so I'm just going to go ahead through and write what I get. And really, other than the underlined and the circled numbers, digits, you are not looking at any of the other digits. So I got 700,000, 30,000, 50,000, 30,000, 800,000. And ultimately, almost all of them rounded down except D. All right, and we're going to flip the page. And we're just going to look at this. Now, for this, we're going to kind of play with some of the more inner digits. So we're going to go down and work with this one first, and then we'll go back and do the other one. So if I'm rounding to the nearest 100, okay, I am looking at the 8, circling the 4. So when you're working on in the inner number, like when we're not working with the most left. So a lot of that first page, we were looking at the most left part of the number. We don't want to touch anything up to where we rounded it, okay? So this is important. Like here, we're rounding to the nearest 100, but we didn't, we talked all about like making things zeros after what we rounded. But what happens before we round, okay? When we do this, we don't want to touch that. So right now, if I'm rounding to the nearest 100, I want to write 135, and now I want to round. Again, the only numbers I really want to touch are the underlined and the one driving that, which is the circled one. So that 4 keeps the 8 the same, which we've talked about. And then after that is where the zeros occur. So I need 2 zeros to keep my number the same length, and I'm done. All right, so now to the nearest 1,000, and I'll try to do it in another color for you. So 1,000 I'm going to do in green, 100 I did in blue. So 1,000 is here, and I'm circling the one next to it. So I'm going to write 1, 3. The 8 turns the 5 to a 6. Once I change or keep the underlined number, that's when I need to write all my zeros. Okay? I'll do red. Whoops. Okay, so now here for, 10,000 is here, and you could kind of see how like why, going in order is important, and like why one task builds on the next. I'll always put things in order, and if you have a question on one task, it's really important that you understand it before moving on to another, because you see like this one, understanding rounding is all about understanding place value, right? So 10,000, we're looking at the 3, and the 3 is dependent on the 5. So the 5 is telling the 3 that it either needs to be a 3 or a 4. 5 says the 3 needs to turn into a 4. I keep the 1, the 3 becomes a 4, and then I put zeros everywhere else to keep the length of the problem, and the commas will help you figure out how many there need to be. Okay, and then finally, 100,000, which is right here, and I'm looking at the 3. So I don't have anything to write ahead. This is like really what we practiced on that first page when we're looking at the most left thing. The 3 keeps the 1 the same, and that's the only one I keep. Everything else reverts to zeros. Okay? So let's try this next one. Okay. So to the nearest 100, I'm looking at the 5 and the 3. The 3 says the 5 needs to stay the same, okay? And everything up until that point needs to be written. The 5 stays the same. The other 2 become zeros, okay? The 1,000. 6 is the 1,000, which makes 5 the bus, right? The bus that gets driven, all right, or the driving bus. So 5 turns the 6 into a 7. It bumps it up. So I get 2, 8, 1, 7, 0, 0, 0. Okay. 10,000. 10,000 is the 1, and we look at the 6. Remember, I think I didn't say it before this, but on a problem like this, we're always going back to the original. We're not rounding off of the one that is already rounded. We're going back to the original problem, okay? The 6 turns the 1 into a 2. It bumps it up. So we start by writing 2, 8. The 1 turns to a 2 because it's bumped. And then I fill in the zeros to get the original digits of the problem, which is 7, 2,820,000 for this problem, or for this piece of the problem. And then my final one, we're looking at 100,000. So that's the 8 and the 1. The 1 does not bump the 8. The 1 keeps the 8 the same. So we're going to write 2, 8 stays the same. And then we get enough zeros to keep it the same, which is 2,800,000. All right, so you need to go back. You need to try it again. Do it. If you think you're ready to try it independently, do that too. Check your answers with my key. Reach out if you need help, and I will see you Tuesday.